A car passes a parked police vehicle. A car passes a parked police vehicle. So here's your parked vehicle. It passes it and continues at a constant speed. The police car begins accelerating at a constant rate when it is passed. The diagram indicates the distance in miles the police car travels as a function of time in minutes after being passed by the car. The distance the other car travels can be modeled by the following equation. How long does it take for the police car to catch up with the other car? Okay, so we want to set these two equations equal. Let's do second plus 712. Our first equation, again, this is distance equals rate times time. So we're going to have distance equals rate times time. This is our first equation, and this is our second equation. How far you go is based on how fast you're going for what period of time. So I have 0.8, working with small numbers here, we'll have to adjust the window, and 2.5x squared. There's your constant rate, and here's where you slow and then you start to accelerate fast. We want to know right down in this area, so let's go right now. Let's go 0 to 1 and see if we can see things, and 0 to 1. We may have to even zoom it in more. Okay, so here's where they're at the same position, and then one is accelerating at a constant speed, and then the other one will eventually catch up with it. We want to know, where do they meet? Your x-axis represents time, and this represents distance. So we're going to use the intersect function. First curve is just the first equation we plugged in, second equation we plugged in, and where do they intersect? Okay, let's round right now. It does not state what to round to, so let's round to the nearest, let's do to the nearest tenth. Your test will say what to round to. So the question says, how long does it take? How long is in terms of time? Again, your x is like your t value, it's time. So it would take, and this is actually exact, 0.32, and this is in terms of times, which is in miles per minute, so 0.32 minutes. Originally I said let's round to the nearest tenth, but since we did have a terminating decimal, which means it ends, I just wrote down the exact answer.